Hello friends, welcome to my channel. So in this video we will discuss about that today problem of the day that's name is sequence fun. Okay, so you have a given a sequence like 2, 5, 16 and 65 and so on. So you have to be given an input n and you have to be tell about that at nth position. So what would be that a sequence, what would be the value of a particular sequence. Okay, so just like it at n is equal to 4, so your output sequence is a 65. Okay, at n is equal to 10, so your output is 9864101. Okay, so what is that a series like that? We have to be discuss about that. Just like it 2, 5, 16 and 65. Okay, and so on. So at n is equal to 1, at n is equal to 1, so our sequence is that 2. At n is equal to 2, at n is equal to 2, so our output is that 2 into 2 plus 1. How it is possible? At n is equal to 2, that our position is 2, so this is our position, this is our position of that. It is like that where I am standing at here. Okay, so this is our position. So this is our position. Okay, and this is a previous value. This is the a previous resultant value, that is 2. Okay, so it is present and add here and add with the 1, so our answer is that 5. Okay, just like it at n is equal to 3, so our position of at n is equal to 3, so this is our nth value, so this is our position of at n is equal to 3. Okay, and at this and this is the previous value, previous is resultant value at present at here. Okay, and add with the 1, so our answer is 16. Okay, at n is equal to 4 and at n is equal to 4, so our n value is 4, and we will multiply with the 16, which is a previous value, and add with the 1, so our answer will be get it that like 365. Okay, you can solve it with your own. So you can know that how it is a internal series like a working. So what is the pattern like it is, you can easily find it. So how it is, how you can solve it, firstly that like you can solve about that a recursion process like that. At at f is equal to nth position, f at f is equal to nth position, so what you will do, you will simply multiply with the n, and what you will do, you will simply call that fn minus 1. Because of that, this is the resultant value, of a previous answer, just like it. This is the 16, this is the resultant value of at n is equal to 3. Okay, at n is equal to 3. I hope you all are understood very well. Okay, so this is the multiplication of a previous value and add with the 1, and after the resultant, you should be divided with the modulus. I hope you all understood very well. That like it is the recursion process. So you should be optimized by the help of dp. So what you will do, you will simply store into the dp, how it is storing like that. At n is equal to 1, when our n is equal to 1, so we know very well that dp at n is equal to 1, dp at 1, so we will simply store that 2. Okay, so firstly we will initialize that a dp at of size n. Okay, and for that is and we will simply at n is equal to 1, we will simply store that 2, and for the nth value we will simply do the for loop till I is equal to 2 to I is equal to 2 to n. Okay, and each and every time what we will do, we will simply add the dp ith position with the value of nth into into dp of previous value. Dp of previous means of that I minus 1 with addition of the 1, and each and every time we will simply divide by the modulus, divide by the mode. Okay, at the end we will simply return that dp of n. Why? Because of that we know very well that nth position we have to get it our the final answer. So this is working fine, but this space complexity is a order of n, and time complexity is also that order of n. So our problem demand is that we have to be solved at a space complexity, at a constant space complexity. So how should you convert into that a memoization to tabulation, to how to convert with a tabulation? So basically this is a very simple logic, nothing you will do. So what you will do, we will simply declare a two variable like a previous, okay, and cur. Firstly we will simply declare the previous equal to 2, previous equal to 2, and what we will do, we will simply run a for loop from I2 is equal to at I is equal to 2 to n. I hope you all understood very well that you know very well that how it is the procedure of dynamic programming. So without any dynamic programming, so you can't understood very well. So please recommended that you will understand about that dynamic programming logic. So let us discuss about that problems. So how you can solve it, you will simply get the current value with the addition of n into with the multiplication of n into previous value. Previous means that which is have to already stored at 4 at n is equal to 2. Okay, so this is a previous plus 1. Nothing is you will do. This is a very simple logic. This is a very simple logic. Okay, and what we will do, we will simply each and every time update our previous with the curve value, with the curve value. Okay, with the curve value. So this is our curve value, and we will update our curve, and at the end we will simply return our curve. So at the end we will simply return our that's like a previous. I hope you all understood very well. This is a constant space, but you can also optimize our constant space in a one space, because at here we are required like a two variable previous and current. So you can simply optimize into the single variable like a curve. Okay, we will simply declare a curve at by the value 2. Okay, so what you will do, you will simply nothing, you will simply uh, erase this previous value, erase this previous value, and what you will do, simply multiply with the curve and update each and every time with the curve. Okay, and nothing you will update the previous value. Okay, and simply return our previous, and simply return our previous. So sorry, simply return our curve value, because we have to be, because we have uh, we don't have any previous variables, so we will simply return our cur. This is our final answer. I hope you all understood that recursion, memoization, tabulation with tabulation with a two variable, tabulation with a one variable. Okay, so let us discuss about that a code. Okay, so here is the solution of a C++ like that. Firstly, we will declare at a mode 10 to the power 9 plus 7 because that's our problem demand. Okay, and long cur is equal to 2, so because our problem demand, and we will run a for loop and update our cur each and every time. Okay, and they return our cur. Okay, so this is working fine. You can simply check it. So this is working fine. Okay, and here is the solution of Java. Same logic, nothing is changed. I hope you all understood very well. This is also working fine. You can simply check it. Okay, if you have any problem, so please comment. Please like my video. Please subscribe my channel. Please share my video. Thank you.